All right, you guys, I wanted to give you a quick introduction to this review worksheet for the exam on experimental designs. So let me first start by going through this story problem. So you're reflecting back to yourself about the first Psych 391, in this case, 3091 class period of the semester, and thinking, man, I really stayed focused that time. I must be pretty amazing. But then you remember the sage words of the behaviorists Watson and Skinner, who claimed to be able to control behavior just by manipulating the environment. But is it true? Did your class environment really allow you to focus better? Just maybe you think my attention had to do with other factors besides my sheer awesomeness. So thinking back on that first class period, you recall, and sadly, in fall of 2020, I decided to cut you some slack, let you go a little early, and we did not sing a song about statistics. But most other classes sang a song about statistics, so that's a plus. And you recall, unlike last semester, which lacked any theatrical flair, Dr. Oaksmuller blew my mind with his talk to me like I'm your grandmother impersonations. I mean, come on. His old lady voice is spot on. So, in classic research method style, you decide to design a study, taking into effect these variables, to see if, given the right conditions, others would perform similarly well on a measure of attention. So you randomly assign half your participants to sing a song about the material during class, and the other half to refrain from these kind of vocal acrobatics. Then you divide each of these groups into two, subjecting half of them to a series of uncomfortable grandmother impersonations, and the other half to a lecture free from such dramatic luster. Then you measure their attention. So a 0 is no attention at all, and 10 is perfect attention. And the following are your data. Remember, each one of these numbers you see here represents a class or a group mean. So here, what we see is that on average, people who did not sing a song, like 2020, and had no grandmother voice had attention levels of 2. People who did not sing a song and had grandmother's voice, you could think of this as our class, you've had no song, but you've had grandma's voice, had an average attention level of 5. Those people, maybe from previous years, who had to sing a song but had no grandmother voice, had an attention score of 7, and who both sang a song and were subjected to my grandmother's voice, had an attention level of 10. So what you're going to do is, given what you know about 2x2 factorial designs, I want you to answer the following questions using complete sentences. So what you're going to try to do is to take these numbers and tell me a story about them. So the very first question is, what is the simple main effect of singing a song on attention when students have sat through a grandmother impersonation? Okay? So I'm going to point you for this question where I want you to take a look, and then I want you to try to answer the question. You're going to do the same thing down below for the second set of questions as well. So here, singing a song on attention. So what we want to know is, what's the difference between singing a song and not singing a song? But we only want to know it for people who sat through a grandmother impersonation. So really what we're interested in is the simple main effect of song singing within the grandmother's voice condition. So we're going to take a look at those two numbers. And what I want you to do for this first problem is to give me an answer describing the simple effect of song within this condition. Next, for the second question, let me erase some of this. For the second question, what is the overall main effect of impersonating grandmothers on attention? What I simply mean here is, what's the overall main effect of grandmother's voice versus no grandmother's voice? So for this one, what you're going to try to remember is, how do you figure out the overall main effect? Which numbers do we compare to get the overall effect of what adding grandmother's voice does to people's attention? Next, what you're going to do is you're going to answer the question, what is the overall main effect of song singing on attention? So what we want to know is, what happens when people go from singing no song to singing a song on average. So when we average across, for instance, the no grammar and grammar voice conditions, and we average across these two conditions in the song singing condition, how does it differ when you sing no song versus singing a song? So moving from one to the other, from one to the other. Okay, so I want you to try to describe this in a sentence, and we'll go over these in class. Next, if there's an interaction, so first thing you want to know is take a look at these data and try to figure out, is there an interaction or not? How do you know that? Well, you might just be able to take a look at the numbers and tell it. You might also want to try to graph the data. So here, if I had, let's say, no grandma's voice and grandma's voice, no grandma and grandma, and if I had song and no song, what I might want to try to do is to graph those. So let's just take, let's go, sorry. You're going to want a circle for one of those. So let's do a circle for no song and a square for song. So in the no grandma's voice song condition, no grandma's voice song condition, what I'm going to do is graph a 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to have a square there. In the grandma's voice song condition, what I'm going to do is graph a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Grandma's voice song condition, I have a 10. So that's what those two song conditions are going to be graphed out. Now in the other one, the no grandma voice, no song, I'm going to go no grandma voice, no song. That's here, 2, 1, 2. And the grandma voice, no song, is going to be 5. 1, 2, 3, 4, 5. So I want to take a look at that data and figure out, is there an interaction? If there is, describe that interaction. If not, describe how you know that there's no interaction. Okay, so that's the first 4 questions. And what you're going to see down here, and then for the 5th part of that, I want you to try to take that data and make a recommendation to professors considering using either one or both of these strategies. What should they do? Should they have their students sing a song? Should they have their students, should they be impersonating grandmothers to their students if attention is their primary concern? So try to make a recommendation. Next, below this, what I've done is given you the exact same problem, but you'll see with different data points here. So you're going to answer the exact same set of questions, but this time you're going to take a look. So for all these down here, you're going to look at this data. Okay? But these questions are identical to those that you asked for the first set of data. Next, what you want to do is I've given you here an incomplete Anova table. Notice there's no sum of squares, there's no mean squares. Don't worry about it. Don't get stuck on this. You can imagine that there's data in there, but you don't need to know it for the questions below. What I want you to do here is look in particular at the degrees of freedom. Okay, the degrees of freedom. And using those degrees of freedom, I want you to first tell me how many participants were there in this experiment. Okay, you want to think about what degrees of freedom do I use for that, and how can I work from these degrees of freedom back to the number of participants. How many groups were there in this experiment? Third, was this a simple experiment, a multiple group experiment, or a factorial experiment? And how do you know? So take your best shot at this, what you know about those 3 different experiments, and take your best shot at answering that question, and we'll talk about it in class. Okay, you are going to do the exact same thing down here. Okay, we have now a different set of degrees of freedom, and you're going to answer the exact same 3 questions for these. We'll talk about them in class. Next, what I want you to do on this page is I want you to take a look at these 3 sets of data. So what you have here is you have participants. You can imagine that this is participant number 1, participant number 2, number 3, number 4, number 5, etc. These are data from 5 different participants. or sorry, from 12 different participants. And what they are is, and you can imagine that these are, let's say they are relaxation numbers. So this is how relaxed someone is. Okay, don't get too caught up on it, but each person has a relaxation score. Okay, these are individual scores. And what I want you to do is a couple things. First of all, and I'll do this for one of these. So what I want you to do is to take a look at all the people in one condition. This is the no treatment condition. And you're going to try to calculate what does the group mean. Okay, so to do this, I'm going to go over here and I'm going to go 5.0 plus 5.02 plus 5.0 plus 5.02 equals 20.04 divided by 4. Okay, because there's 1, 2, 3, 4. 1, 2, 3, 4 pieces of data. So the average or the group mean for this group is 5.01. So 20.04 divided by 4 gives me 5.01. So the first thing you're going to do is do the same thing over here. Calculate out the group means for each one of these 6 different groups. Okay? That's the easy part. The second part is more conceptual. So you're going to do that. So you've done that up here for each treatment group. In the second experiment, I've given you data as well. Okay, you're going to do the same thing down here. You're going to calculate those group means right here. Third, and this is the more conceptual part, we're going to talk about it in class. By examining the scores and the group means, I want you to try to identify which experiment is more likely to find significant differences between groups. In other words, which experiment is more likely to yield a significant F value. Okay, I want you to try to figure out how to do this. All I've given you are, you've calculated out group means, and what you can tell are how different people are within a given group. So remember, in general, our F is about between group variance over within group variance. Okay, so just give it, you can't calculate out F values for this, or you could, but it would take a long time. Don't worry about doing that. What I want you to do is just to take a look at the between group variance and the within group variance of this experiment, and then the between group variance and the within group variance of this experiment, and see if using that information you can tell which experiment is more likely to find significant differences. Next, so this is either going to be experiment A or B. You'll either put A, oops, sorry, I shouldn't do that in a highlighter. You either put A or B for this answer. You got a 50-50 shot at getting it right. Down here, what I want you to then do is, using the kind of terms that we've talked about in class from the book, describe why you expect that experiment to yield significant results. So try to explain why you answered either A or B above. And we'll talk about that in class.